Hi. So this is the second video of this operating system playlist. Okay. So the first thing is what is program and what is process and what are the differences. Okay. I will not be spending more time on explaining what is program. So program is a set of instructions. So far you have already written few programs. You have seen people writing programs. Even you have also written some. Maybe you have written multiple number of programs. Okay. So I will not be wasting time in explaining what is program. As of now, I will more spend more time on explaining what is a process. Okay, what is a process? I will come to this part slightly later. But before coming to this point, I would like to cover this thing. So the next question is how a process is different from a program. That means what is the differences between a process and a program. So in one line, if I have to give you a maybe answer, that will be, let's say you are adding some life to a program. Now this program with life is called a process. Okay. So what is life? In order to become a process from a program, this program requires some resources. Okay, what are those? I mean, what are those resources? I will come to this slightly later. Okay, now for now, just one line, that is, in order to become a process from a program, okay, this program needs some resources allocated. Okay, so these allocated resources are nothing but life. So once there is a program, okay, once there is a program and you are allocating some resources, now this thing is becoming what? Process. Now I will be coming to the real world example. Let's say this is a guy sleeping in his room, okay, in the night. So you can compare this scenario with a program. This is sleeping, this is not doing anything. This is not under execution, not working, not eating, doing literally nothing. Okay? And this the same guy is running for his office. So let's say the guy is sleeping at 6 a.m. His alarm is ringing. The guy wakes up, he prepares himself by wearing a shirt, by wearing a pant, by wearing shoes, or by preparing this office. I mean, by preparing his office bags. Okay. So in this example, what are those resources? Those resources are his I mean, the pant he's wearing, the shirt he's wearing, maybe the shoe he's wearing, the bag he is taking. These are the resources. So this is program. Okay. He is getting those resources and he's running for his office. So the moment this guy is starting to run for his office, that moment this is called a process. Okay. So in this example, this guy prepared himself. Okay. What do I mean by prepared himself? This guy himself allocated those resources that he requires to go for the office. Okay. But in computer science thing, operating system is the one who prepares a process out of a program by allocating the required, by allocating the required resources. Okay. These resources are not fixed. These resources will be changing depending on the program. OS decides, okay, this is a program. In order to become a process, what are the resources this program requires? Now operating system allocates only those resources, and that is how this program becomes a process using the help of operating system. So now I'll be coming to this more real example, computer science kind of example. Okay, let's say you have written a program that is hello.c. So obviously this is high level code you have written. You have given this code to your compiler. Okay, and as a result, your compiler has produced this a.out file. So this is a low level code or maybe binary code. So this hello.c and a.out both are program sleeping just like a sleeping files. Okay, he's not doing, I mean, this program is not doing anything, is not under execution, literally doing nothing, just sleeping in hard disk. So now where this program is, the moment you are saving, let's say you have written a program like hello.c and we have compiled also, this a.out is created. What do you think, where this file is saved? This file is saved in your hard disk. Let's say this is your hard disk. Okay, in this hard disk a.out, a.out file is stored. So the moment this file is stored in the hard disk, this file is called what? Program. So let's say in the next moment you are planning to hit this command. By planning to hit this command, if you hit this command, what it says to operating system that, hey operating system, I want to execute this a.out program. Okay, now operating system knows, oh, I cannot execute a program. In order to execute a program, I need to make a process out of this thing. Okay, So now operating system will come. Operating system will be allocating the required resources to this a.out program, and operating system will be making a process out of it. Okay. So the moment this process is made out of this a.out program, this process is loaded into the RAM. Once this a.out, I mean this process corresponding to this a.out program is loaded into the RAM, now this process is ready to be executed by the CPU. Okay. So process is nothing, process is program plus its required resources that I called as life. So if I come to this point, I will come back, I mean let me come back to this point. So this is, what is process? Process is a program that is under execution, okay, and stays in RAM, okay, with resources allocated. So you may find some program, I mean you may find some processes which are not staying in RAM, okay. So going forward, you will get to see those scenarios as well. But for now, just consider this line, okay. For now, just consider this line. Okay, let me go to this part. Okay, so this is another example. So far, I have taken this hello.c a.out example. I hope this is clear. This is program, and the moment this is, I mean, resources are getting allocated, and this is getting loaded into RAM. This is ready for execution. So at that time, this is called process. Okay, this is RAM, and inside this process is loaded. Okay, I have taken this example as well. The guy is sleeping. I have compared this with this sleeping phase as program, and when alarm clicks in, the guy wakes up and runs for his office. So the moment he is running for his office, he has become a process. Okay, these are the two examples I have taken so far to teach you the difference between program and process. Now I will be coming up with a more realistic example, okay, which you can see in your daily life. Let's say you have installed, I mean you have downloaded this file. Which file is this? Let's say this is chrome.exe. Fine. So the moment you have installed this Chrome, you will be getting such an icon. Okay. So the moment user is clicking on this Chrome icon, that moment your operating system knows, oh, the user wants to run this Chrome application. Okay. Now what happens is operating system creates a process out of this program. Which program? This program. Okay. Operating system creates a process out of this program with all the required resources and loads into RAM, so that you can, I mean your CPU can execute the instructions present in chrome.exe. Okay, fine. So operating system creates a process out of this program with all the required resources and loads into RAM. Fine, I have explained this thing up to this part. Fine. Now your Chrome has a process in the system. So the moment this Chrome process is in the system, now your CPU will be able to, as I just said, your CPU will be able to execute this Chrome process. So the moment this is present in disk, this chrome.exe, this is called program. Okay, user is trying to run, operating system will come and make a process out of this program. Fine. Right after that, this process is loaded into RAM. Okay, loaded into RAM. So right after loading, why this loading happens? Because your CPU can talk to only RAM. Okay, as of now, just consider. And one more thing, CPU can talk to cache as well. But as of now, I am not introducing your cache. So as of now, just consider your CPU can talk to RAM. Okay, CPU will talk to RAM, will refer the instructions present in this chrome.exe. Okay, and execute those instructions, and you will end up seeing the result on your monitor. Fine, whatever I have explained, this is just in written format. Fine. So this is one more live example. So this is something called activity monitor. I have taken it from a MacBook. So in Windows, there might be something similar to this activity monitor. So this is a snapshot. So these are the process names. So if you refer these are the processes that are running in the system. So what are these things and what are these things? You will be automatically understanding right after finishing this operating system course. Okay, so this is the fun of operating system. Whatever you can see in your gadget, maybe your iPad, MacBook, mobile, whatever you can see, you will be able to relate to the concepts that you are learning in operating system. This is the beauty of operating system. Okay, fine. Now the next question: how a process looks like. Lot of theories on process. Now my question will be how a process really looks like. So a process looks like something like this. A process requires your code that it has to execute. Okay, like in this example, let's say the hello.c file was there. So for that example, this is a.out. Okay, there is another section called global and static variables place. I mean global and static variables place. What happens is So this place is allocated for all the global and static variables present into your program. And when these are initialized? These are initialized at the load time. Alright. So this is the use of this space. Okay. And there is one more space. This is totally dynamic space. What happens in this space is from, in this space we have two sections. One is stack, another one is heap. So what happens is your heap grows upside and your stack grows downside. Why so? So because initially we don't know how much space your heap will take and how much space your stack will take. So as a result, what we do, from one side your heap grows and from another side your stack grows. Fine. All right. So that is how that that is why these two things goes from the opposite direction to each other. Okay. So what we store in the heap area, in whatever space you are allocating by malloc or calloc or any space, you are dynamically allocating. Okay. All of these dynamically allocated space are getting occupied in this heap space. Okay. Another one is this stack. Okay, stack space. What happens in stack space? This stack space stores the temporary data used by function calls. Okay, you will get to see this, what this thing really means. And the stack area grows and shrinks as function is called or returned. Okay, so I have to explain this, I have explained this, I have explained this. This I am yet to explain. Okay, I will come to the segmentation file slightly later after covering the stack. Okay, let's say you have a method called main method. Okay, so you have four lines of instructions. Line number 1, line number 2, line number 3, line number 4. This is the last line. Okay, so line number the moment your main method is called, there is one entry pushed into your stack. Okay, this is called the main. So there will be line number 1, x equal to 10, then y equal to 20. These things are stored. Okay, in line number 3 your program sees, oh, I am supposed to call this another method which is add. Okay, now this add 10, 20 is getting called. So the moment this is getting called, this add method is getting called, one more this entry will be pushed into this stack. Alright. Initially you had this only one entry. So the moment this add is called, you have pushed another one entry. So what happened? With the function, with the moment you are making more function calls, you are ending up with more stack sizes. Okay? Because for every function call, you are adding one entries into the stack. Fine. So this function is successfully executed. Let's say this is returning 30. The moment this is returning 30, this return operation is taken place. At that moment, this entry is popped out. Fine. Now again, this main method comes into the game. There is something called PC, that is program counter. I'll be explaining more things on program counter, but as of now, just consider program counter says what is the next instruction your CPU has to execute. Okay. So the moment from main method, the moment from your main method, this add function was called. Okay, what is the next line that is supposed to execute? Line number 4. That is why PC was storing 4. The value is 4. So when this main method is under game again, under execution under CPU again, your CPU says, oh, the PC value is 4. Now what happens? Your CPU goes and refers this line number 4 and your CPU says, oh, there is nothing to be executed in line number 4. So that means main method is done. Main method will be returning something. Okay, it's not finished. Let's say maybe there might be return 1 or return 0, anything, something like this. Okay, so the moment your main method is returning something, this main method is also getting out of the stack. So whenever you are making more function calls, you are ending up with more entries in your stack. Once these functions are done with the execution, this each and every function gets returned. Okay, so the moment a function is getting returned, what happens is that particular entry from your stack gets popped out. As a result, what is happening is when each of the function is getting returned, you are just popping out that particular entry from the stack, and that is how when your functions are getting returned, your stack size shrinks, and when you are making more function calls, your stack size is growing. Okay, this part I skipped, that is segmentation fault. So this is the set of instructions and this is the space that is allocated to this process. Let's say any of your instruction is trying to access some space which is out of the boundary of this process. Okay, which space operating system has not allocated to this process. So at that moment you will be facing an issue, an error called segmentation fault. If instruction tries to access space beyond allocated space, That is called segmentation fault. Okay.